Hi everyone, I am Jessica and I'm going to be talking about semantic fingerprints, which are a new approach to natural language processing developed by a company called Cortical.io. So everything that I'm about to discuss really comes down to one central issue. And to borrow from the way that Cortical's founder expressed this, computers are really good at processing values. In fact, they're designed for processing values, right? So we can really easily do some pretty complicated stuff as long as on some level we're still dealing with numerical values. But as soon as we start dealing with human languages and say, okay, what's the value of the word bicycle, then things start to get a lot more complicated. And what we're talking about here is the field of natural language processing, or NLP. And I know that that's a big buzzword right now, but this is actually an issue that we've been tackling for years. And for the past several decades, the prevailing approaches to NLP have all been through statistics. And without getting too much into it, statistical approaches to NLP typically attempt to generate some kind of computational model for language based on statistics such as word count statistics, to give you an example. And what I want to show you today is a technology developed by this company, Cortical.io, and they've developed an approach to NLP that, rather than being based on statistics, is actually based on semantics. And in other words, they've developed a schema for representing the actual meaning of individual words. So the approach was inspired by neuroscience research that showed that every single piece of information coming into our neocortex, regardless of where it's from, whether it's from sight or touch or sound, wherever it's coming from, it all has the same format. And it all comes in encoded in something that looks a little bit like this. And what this is a huge vector with thousands and thousands of bits. And each bit represents a very specific piece of information. And at any given point in time, only a small percentage of those bits are activated or set to 1, and the rest of them are set to 0. So I hope the terminology is giving you a little bit of an idea of where I'm going here, and that's that it's the data structure. So all of the information coming into the brain is really just a series of 1s and 0s, or it comes in a way that can be represented as a series of 1s and 0s. So this is huge, because if everything coming in can be 1s and 0s, then language can be 1s and 0s, or meaning can be 1s and 0s. So that's exactly the idea behind Cortical.io's concept of the semantic fingerprint. And their mission was to programmatically represent the meaning of individual words using 1s and 0s. So in a highly schematized fashion, an individual fingerprint might look something like this. Okay, so if we take a look at an example, for example, the word dog, we can clearly see that we have some bits activated. The yellow bits are the activated bits. And each of them represents a very specific piece of information. So what's really interesting is if we go in and inspect each of those bits, we'll see what they refer back to. So if we take collar and bark and fur and ears, those all contribute to the overall meaning and our understanding of the word dog. And to take it a step further, if we look at another fingerprint of a similar word, we'll see that the things that these two words have in common are both activated by the same bits in both fingerprints. And by that same token, the bits that are activated in one fingerprint and not the other, we immediately know these are the semantic differences between the two. And this is something that's very visual and can very immediately be derived just from the visual representation of each fingerprint. So a big question at this point might be how we actually create the fingerprints. And I do want to get into this just to point out how this all happens in an unsupervised manner. So the first thing we need to do is select some literature for our semantic space, or the semantic map. And this can really be anything, but to give you an idea, the English API that Cortical makes available is based on the entirety of the English language Wikipedia, but it can really be anything. And then the text is cut into little snippets, and the snippets are distributed over a two-dimensional grid where snippets that are very similar to each other are close by, and snippets that are very different from each other are very far away. And the similarity of two snippets is just determined by the number of words that they share. And so when this is finished, we have our entire semantic map. Once we have that, we're going to go ahead and use that to encode the individual fingerprints. So for each word in our semantic space, we examine all of the snippets that we have on the map. And when we have a snippet that contains that word, we're going to activate that position on the map. And once all of the snippets that contain that word have been activated, we have our fingerprint. So I know all of this has been really theoretical so far, so I do want to hop into a demo very soon, but I do want to point out a couple of things before we do so. The first is that even though so far we've been talking about fingerprints for individual words, they can actually be generated for any unit of text. And we can do that by layering the individual word fingerprints on top of each other to create a new unit. So that means we could represent an entire phrase or a sentence or an entire book. We could represent an entire book using a single fingerprint if we wanted to. And the second thing I want to emphasize is that the practical applications for this technology all come down to one central piece of functionality, and that's the similarity operator. So we can always determine the amount of semantic similarity between two fingerprints by measuring the amount that they overlap, the number of activated bits that they share. Okay, so those are the two things I want you to keep in mind, and we're going to hop into a demo. And I would actually like your help for this. So I mentioned before that I would like you to have your cell phones ready. So if you could go ahead and get ready to text this number that's on the screen, we're going to generate some text together. Okay, so just raise your hand when you're all set, ready to text this number. Okay, great. So I want you to go ahead and text to this number just the first 5 things that you think of. Just completely free, well, not too free because it will show up on the screen, but some free association, just the first 5 things that come into your head. Just cats. Okay, there we go. All right, so I think we have some text. So go ahead and take this wonderful nonsense string. Oh, more cats. Okay. All right. So I want to hop over to the Cortical Similarity Explorer that they make available on their website. And I am going to go ahead and compare our string of text to, let's see, the word dog, for example. You know what? Let's do, yeah, dog should be fine. Okay. And let's see what we get. Okay, 32% overlap. All right, that's actually pretty impressively large. I think it may have to do somewhat with the amount of cats that we had in our string. Okay, so we'll see on the left side that this is our fingerprint for our somewhat nonsense string, and on the right is our fingerprint for the word dog. So we can see visually that these two fingerprints really don't have that much in common visually, even though our percentage is not too small. But we can immediately see that these two things are not necessarily they're not necessarily two things that are semantically similar, and why should they be? So I want you to go ahead and text to this number again, and this time I want you to text me the first 5 things that you think of when I say the word dog. Sensing a theme here. Okay. Oh wow. Okay. That's okay. We have a lot of ideas. Okay. Great. So let's go ahead and plug this into our Similarity Explorer. There's still quite a number of cats. And let's see what we get. Okay, well, our similarity increased actually by only 2%, but I want to show you something cool, which is that visually we can actually start to see some patterns emerging that both of these fingerprints share. So we have a little bit of a cluster over here in the dog fingerprint, and we have that same cluster over here in our string. We also have a little bit of a cluster down here, and we can see that same pattern down here. So visually, it's immediately clear to us that these must have some kind of semantic similarity. And what's really interesting is that we can go in and inspect the individual parts of the fingerprint, and if the orange represents the parts that overlap, we can immediately see what those are references back to. So this is a really cool tool that can really be, we can use this on any amount of text, on any string or any unit of text. Okay, so I'm going to hop back over. And talk a little bit about the practical applications of this. So the biggest or the clearest example of a practical application for a semantic fingerprint would be searching or information retrieval. So if we're searching by a keyword, what we're doing is basically string matching. And that's not terribly flexible, and it's not semantically grounded anyway if we're just matching a literal string. But if we switch gears and match instead based on a semantic fingerprint, we can actually look for a specific meaning. So say that we are looking for a certain term, and we generate its fingerprint. And we have, on the other hand, a list of documents, and we generate all of their fingerprints. We can go ahead and rank all of those documents by the amount of overlap that they have with the fingerprint for our search term. So immediately, we're able to do much more flexible searching, where the word that we're actually looking for might not even be in the text that we're searching, but they have a similar meaning. They have a similar context. And a second application is classification, where if we have a word that's a classifier, again, we can generate its fingerprint, and all of the words that belong to that category or that classification will have a higher overlap with that fingerprint. And to wrap up, I wanted to give you just a few things that you might want to look at if you're interested in this topic. The first is the Cortical website, where they have a ton of demos using their API, like the one that I just showed. And you can read a lot more about this technology on their site. Another resource is the hierarchical temporal memory theory, which was actually the neurological basis for this technology. And the last is the semantic folding white paper by Francisco Weber, who is the founder of Cortical.io. And this paper goes into a more detailed explanation of the process methodology for the semantic fingerprint. And that's about it. Thank you.